Thank you. Thank you. Thank you very much. In terms of getting started, um, thank you very much for inviting me to give you a talk about my ideas or my thoughts on design. I really struggled with the fact of actually doing this talk. The last time I actually did a talk was almost 7 or 9 years ago. I always refused, but I decided I was going to come this time and to try and explain my thoughts on design. I thought it would be best to do it from a personal level. Design, I always believe I'm one of the luckiest person on the planet. I was born to Nigerian parents. My father was way ahead of his time in terms of the way he thought. And he wanted to do architecture, and he was in the UK. He did all the, back in the 50s, mid 50s, did all the qualifications, but the RIBA will not let him in. And that was the situation back then. So he became a surveyor, and his passion for design was amazing. His hand drawings, the way he saw buildings in space was interesting. And he was one of the first black expatriates to be sent to parts of Africa, West Africa, to open local authorities and explain to people why you should have a local authority, why you should pay your rates, why you should have roads, buildings. And I can remember growing up, me and my brothers and my sister, especially my brothers, he used to give us a piece of work to do once a week. We had to write a paragraph of any subject we can think of. And he also gives us some sums and maths to do. But we also had to draw an object in the house. We had to do a sketch of an object in the house. And our reward for doing this was he bought us Marvel comics. So we actually had some of the original Marvel comics, Spider-Man, Thor. So it was an incentive for us to learn, to actually get used to learning. He was very keen. I was quite good in sketching. He was very keen for me to be an architect. But I got to the age of about 13, 14, and I met a structural engineer, one of his friends. We went on a visit, and I saw this guy sitting on I went to this sort of design studio, this was in the 70s, where you had the architect and engineering all in one practice, and they had a drawing office. And there was one guy at the top of the drawing office on a platform, probably a bit about this size, a bit taller, and he had what we call a double elephant drawing board. I'm sure most of you don't know what that means, but some of the people of age will understand what I mean. In the past, there was no computers. This was before computers. So everything was drawn by hand. So you've got your A1, you've got your A0, and then you've got your double elephant, which is quite big. So the drawing board was probably about this big. And he was drawing on there. I went up to him. I think I was about 13 or 14. I said, "What are you doing?" And he said, "I'm doing a reinforcement drawing." And I looked at the drawing, and it was hundreds of lines. And I said, "Why have you drawn all these lines?" And he said, "This is what holds the building up." And I said, "Do you know where every single line is?" He said, "Yes." "And do you know the meaning of every single line?" He said, "Yes." And I thought, this guy must be the most cleverest guy on the planet. For him to know exactly every single line on this reinforcement drawing. And I decided I was going to be a structural engineer. Now, the problem is, as a young person, being very passionate about design, and my dad encouraged me a lot, it was very difficult back in the 70s to realize that ambition. Going through school, I realized from a very early age that I could get away with murder Actually get away with murder with my parents as long as I am in the top 5 in my class. So, which meant I got away with murder. I was one of the most rascal young men in Lagos. I actually helped organize one of the biggest riots in 1974. I grew up in Sierra Leone, primary school in Sierra Leone, and I remember one time I had a fight with my brother, and we ended up destroying the ironing board in the house. So I spent a week putting the drawing making a new ironing board for the house. I thought my father was going to kill me, but he got back from the office. He saw me putting this thing together, and he just joined and helped me put it together. Now, small things like that, as a designer and a creator, sticks in your head. Design to me is not just about fancy drawings or idea of space and the usage of the fill, colors. It's a lot more than that. And it's fascinating in my older years working in the States, trying to see the difference between Europe and America and some other parts of the world as well. My early years, this is Freetown, where I grew up, this Freetown in the late 60s, early 70s, and the center of town is this cotton tree. And it's always fascinated me that the whole town of Freetown looks up to this tree. And as a young man, when it starts raining, it was a space for people to congregate. When it's too hot, it's a space for people to congregate. And when you look at it, I mean, this is even before this building, this more modern photo. Most of the buildings back then were sort of quite low. This was nature creating a space that is useful to people without any interference from human nature, apart from the fact that there are a building surrounded. And it's still there at the moment, and it's still a symbol of Freetown. I did my secondary school in Lagos. I thought I was the hippest guy in town, always with my bell bottoms and afro and what it was like in the 70s. But growing up in West Africa, there was no hint, not a single hint, of you not being able to do what your dreams are, of trying to get to do what your dreams are. Always encouraged, and always people striving to actually achieve their ambitions. Now, I got to the UK I went back to the UK at the age of 16, and all my troubles started. Because in 1978, in my class of 72 in structural engineering, I managed to get to a university because there was only colleges, polytechnics, and universities, and you had to get into a university if you did A-levels. I didn't do A-levels. I did a diploma because every black person were pushed towards the colleges. They want you to be joiners, carpenters, bricklayers, but not professionals. But I was determined to be one. So I managed to get myself into a university, Bradford University. There was 3 black people in a class of 72. 2 left within the first term, right? The first term, the first 4 months. And I think one left just in about 6 months. So I was the only one left. Going to college or going to classes was like going to war every single day. It was the fact that you make one mistake and you were out. So for my 4 years, I realized that during that period, it got better, not because the situation around me got better, but because I had to find a solution to it. This was my solution. I was in a class once where even my lecturer grabbed me by my collar and pulled me up against the wall. It was that bad back in the 70s. But I was determined I was going to stay. So I managed, as the only black person, to finish the course after 4 years. Then I was invited. Our two lecturers were very good, and and design and structural engineering did not exist. So the whole conversation about trying to design a beam or trying to design a column that looks good was heavily controversial, which meant there was always a constant clash between me and my lecturers. But I had two supporters. One of them said, Albert, please join the master's course in structural engineering when you finish. I said, I've got no money. He said, don't worry, join it. And by the time you finish or halfway through your course, you realize you haven't paid your fees. We'll both get dragged in front of the financial panel and I'll defend you and you can pay it off when you finish. The ever first master's in structural engineering that was done in the UK was done by 3 universities, Imperial College, Bradford, and I think it was UNIST. And 5 of us in my year did the course and only 2 finished. I was one of them. And even my family said to me, why are you trying to do a master's in structural engineering? For me, structural engineering and architecture work very hand in hand. For me, there's very little difference. But society then did not accept people in that position. But I did it anyway. Best thing I ever did. To survive, I actually started the Taekwondo club at Bradford University. And by the time I got to my 4th year, I didn't have anybody. At one time in my 1st year, I was surrounded by a lot of people trying to knock my head in. By the time I finished in my 4th year, everybody knew I was a martial artist. I became a 5th dan. I ran the club, and I knew it then shifted from a physical situation to a mental situation. In that area, I felt I was more confident, but the physical allowed me to actually be able to take care of the physical, allowed me to go through my studies, basically. So then I end up with a dilemma. Do I carry on? I was in the national team. I was British and English champion for 5 years in the lightweight. Do I carry on as a martial artist, which would have been good, or do I stick to design and engineering? So I decided to stick to design and engineering. But then there was another problem. The next problem was, it was clear that the discord between design and engineering was there. Trying to actually follow your passion in design, and I use the word design, not engineering, was proving very difficult. My very first job was in 1983, 84, after writing the best part of my undergrad. I think I wrote 140 applications and I got 2 responses. And I wrote 160 on the second one and I got 1 response. And that 1 response basically said, you can have the job, but we're only going to pay you half what the average is for graduates. So the average at that time was about £12,000 a year, and I was on 5.5, but I had no choice. That wasn't the point. The point is, you get into the system. Getting into the system then requires changing it. So it was clear to me that the only way I would be able to follow this passion and actually bring design and engineering from my perspective to contribute to society would be I have to open my own practice. Again, very, very difficult, because back then, having worked for 3 practices, which was very, very, very difficult. I did a project with my second employer where designed the very first planar glazing facade in commercial use and a planar glazing roof. I remember my boss said, there's no way we're going to do it. And I said, we can make it work. No. So he went on his 3 weeks holiday. And in that 3 weeks, I got the client approval, got the architect on my side, got it tested at the university, got it approved, and got the contractor in 3 weeks. And he came back and he took me into the meeting room and actually nearly tore the skin off me. And that project put them on the map. And then I found out that I had 2 graduates who I was training as part of my team, and both of them were being paid more than myself. So those are the issues one had to deal with. But trying to open a practice was something else, because in the UK at that time, there was not one successful black architect of any form. I remember David IJ when he started. He virtually went bankrupt twice. He did one very good job, and they refused to give him any work in the UK. He had to come over to New York, and I had to go to Germany. LC Awosu, the same. So the issue here was, if you start a practice, and I can remember when we started, I was told, you're not going to last 2 years. We are now one of the biggest structural engineering practice in London, with about 350 staff. How do you do that? And how do you create this design agenda within a practice? So when we started in 1995, our 2 partners, Hanif Kara and Robin Adams. My agenda was very clear: stay off the limelight. So I'm the principal design director of the practice, and I've stayed off the limelight for a very long time. The practice we started was to create, and as soon as we started, from day one, literally from day one, we had a research team in the practice. We started with 1 person, and we developed it. So this is a slightly old slide, but we're a structural engineering team. The part team is a very important team for us, our research group. And we use them. We've got architects, mathematicians, script writers, programmers, and material scientists all in that group. Their job is to help us create client's vision. How do we do something that has not been done before? And we work closely with them. Then we have a small envelopes team. We look at envelopes not from a point of facade. Facade engineering is one thing. For us, envelope is different. Envelope is looking at the total, not just the glazing, but the solid and any kind of material we're trying to use, and how we can get those materials to perform the way we want it to perform. And our civils team is a tiny rails team where we respond to clients' responses when they do ask us to do some of the civil work. In the UK, civil engineering and structural engineering is very well split. In the US, they're still having problems trying to identify their roles, in my view. There's too much of a crossover, which doesn't help. This slide just shows the areas where we work, and we do everything from London. Deliberately, mainly, so many times we've been asked to open an office in the States, and we've always said no, because I'm a control freak. We like being able to basically control how the process. And we, as a practice, we actually run a unit at Harvard, an engineering and architectural unit at Harvard. We're also at the AA, KTH in Stockholm, and always get invited to a number of universities. But I try and avoid as much as that as possible. My partner, Hanif Kara, does most of that. I just stick with the design. In the UK, we're fairly well established, and I will go through this. And in some parts of the world, we're just showing some of the projects, which Mazda Institute, Zero Carbon City, Phase 1, where it was actually generating more energy than it was using. You got electric cars in there. It's one of the very first electric cars. Each one cost 1.3 million. This was before electric cars existed. And we've done, you can see, the first steel stadium in India, Pune, the vessel, which I'll talk about, ISIN Dakar, etc. Zaidi Halef, and I'll go through some of those. And I want to use that actually to sort of explain how I see design. Design for me is not just something that is taught at an institution. It's about who you are, how you see life, and how you experience not just life, but the spaces and people around you. Understanding the wider ambitions of a client. As designers, you have to go way beyond what the client is asking you to do. You have to go way beyond the visions and even what your lecturers are asking you to do. You have to be very true to yourself in your approach to design. And that's something I totally believe in. I'm just going to go through these quickly. These are some of the projects, but I want to get to. Right, now the other thing is value judgment. I think Europe understands a bit more about value, in my opinion. I may be totally wrong, so don't take me as literal. From my experience, I sort of feel when it comes to buildings and design, Europe understands more the value of design than the US does. There's a lot of issues in the US that can only be adjusted and changed by the professionals yourselves, not by the construction industry. You have to help direct them to actually understand the value of design because it has a huge, both in terms of sustainability, and I mean sustainability in terms of usage. Why do we all want to buy an iPhone? Why do we want to buy different kind of cars? Why do we even have luxury cars? We buy them. It's because there's something about it being used and people enjoying being able to use it, being in a space and enjoying an environment. And the more you use it, the better it is. This is a huge mural we have in our office, which is to remind our staff what we do. It's not about beams and columns and connections and concrete. It's much bigger than that. And understanding, having a wider understanding of everything in our industry does is important. Design requires engineering, architecture, landscaping, interior design, colors, the environment. I'm just going to go through some of these very quickly. As an engineer, this to me is one of the most important slides I have in my collection. Yeah. As an engineer, you have to question everything. You have to be prepared to question everything. You have to prepare to question clients, you got to be prepared to challenge the architect, you got to be prepared to challenge the codes because people and society use the codes as a way of being super lazy. It is the lowest common denominator to do something. It is not the highest standard of how you do things. But people refer to that as a way of not making things happen. But if you want things to happen, you have to be prepared not to be that way or that way. You've got to be more level-headed and question either way. Now, I've got about four or five projects to try and explain some of these issues. I got a call to actually attend a meeting in San Francisco with Larry Page. And I thought I'll start with something in your neighborhood. I know it's quite a few miles down the road, but I'm sorry. It's still, I suggest to actually come and do a master plan and design with Thomas Heatherwick and Bjarke Ingels to look at how we can create hospital quality spaces for his staff. And it was to look at a series of domes. He's been told that he could do a kilometer dome with an ETFE4. This is where engineers will let ourselves down. And this was to look at a number of domes, and the total area was something like 7-8 million square meters, quite big, on a series of domes. I'm going to go get this right here, million square feet, 700,000 square meters, or about that. So we started working on it, and it was clear that the information he's had for a very long time was wrong. First, nobody questioned why you should have domes. In in the West Coast, you guys have got some of the best air quality, some of the best air quality in the world, really, for in your towns and cities, this mountain view. But he still wanted hospital quality, and that needed to be challenged. So for about 7 years, he'd been told he could do a kilometer with layers of ETFE, and I just told him, no, it can't happen. It can happen in another 25 years, but right now we haven't got the material, the engineering, or the know-how to do it. That didn't go down very well, but it was a good starting point. We end up, and the idea was about Mr. Fuller, the approaches of trying to create this mega dome and you can have everybody inside it, doesn't work. It's not sustainable. The energy you need to hold something like this up is just off the scale. And the implication to the substructure, to the ground, is also immense, which you don't see in beautiful sketches like this. It's an idea. Reality got to come into play. But that doesn't mean you cannot attempt it. So we were looking at domes, and we were asked to look at, we did a master plan for all of it, and then we were asked to look at about 2 or 3 of the domes, and this was one of them, Southside, which was the first one. And I'm going to be a bit naughty. I'm going to name some of our competitors. We were told very clearly that our partner is going to be Arabs to deliver our design, and they struggled. And the issue here is that you need to work in collaboration. And it's not in the DNA of your industry in the US at the moment. There's a really massive divide between the architect designers and the engineers. Trying to get them to actually sit down and work together is pretty difficult. Anyway, I'm going to go through this very quickly so you can see the way we think and the way I think, the way AKT thinks. We went through a number of options, and part of the reason why we actually introduced columns at about, I think it's about 13 meters, because the first dome we looked at was about 300 meters. This is a familiar face. It was about 300 meters in diameter. And the reason was to minimize the impact on the ground. Everybody is worried about climate change and what we do to the surface and what happens to the surface of our planet. People don't think very much about what's happening below ground. It's just as important, absolutely just as important. Trees are dying, not because of what's above, but also what's below. And we're just damaging what's below just as much as what we're damaging what's above. And the idea of doing a clear 300-meter dome meant that the amount of concrete mass we had to put into the ground just to keep it going, the ramification was huge. And we had to say, Mr. Page, this is not a good idea. And it took a long time to get to that position. But what the ambition internally was amazing. What we were trying to create internally to reduce the amount of solar gain and everything. But there's a big question we all have as designers. My generation, in my view, and please, I've got to apologize for my language before I use it. My generation, we fucked the world up. We completely messed it up. Because we started with the premise of we're going to use technology and energy to make ourselves comfortable. The implication of that is your generation and the next generation will have to try and undo that. And what we're going to try and do is actually start changing to say, hang on a moment, why do I need full air conditioning in a room? If I'm a bit warm, take your coat off. If it's a bit cold, get a jumper. If I need fresh air, open the window. What's wrong with the air outside? So we have to change our approach to how we use spaces. And also, we have to train the developers, the builders, the politicians to say, come on, guys, why do we have to knock down every damn building every time we want to do something? That agenda is now well established. 15, 20 years ago, trying to convince a developer to keep a building was a nightmare. So we have to change our approach to some of these. But what they were proposing internally looks incredibly beautiful. But I would hate to actually go back and do the energy calculations on this. It was off the scale. So our task was to actually go through some of these and see our possibilities. So working with our part team, we actually went through a number of approaches using in-house written programs and scripts to actually see how this will perform. Sorry, it's not doing what it's supposed to do. Right, so what we tried to do was actually look at dynamic relaxation as one of the options and force density. Too much technical stuff. You don't need to worry your head about it. But the whole idea is, how do we relax this thing so that the amount of force we need to create the form is minimized? So there's a lot of criteria to make this work, but how do we make it as little as possible? Because when you create a tension member, you need a counterforce to hold it in place. And the implication on that, as I said, on substructure was huge. So we went through a number of processes, but also to reduce the stress diagram. The red areas shows the higher stress areas. How do we change the geometry we were given by the architect to minimize the amount of force we're actually using to create the shape, which means part of the geometry changes. But I don't think that's too much of a big issue. So we went through all of that, and we went through each, not just from a micro level, but also a macro and a micro level, in terms of how we change the idea of a tension structure. So on the right is a cable net. On the left is something we call a grid net. What we decided was, rather than using cables, we use flats, because by the time you align the flats together, it actually has more stiffness, which means it's part bending and it's part in tension, which means you're minimizing the forces and the energy in the system. And we had to go through all the usual analysis, wind analysis, left, right, up and down, different kind of forms to make sure as you can see at the bottom, the amount of force you need to create the shape. And we presented all this to the client to say, look here, this has, as soon as you create more force, you're using more energy. If you're using more energy, not a good idea. So rather than playing the black art or the black magic of structural engineering, which is what a lot of engineers do, you say to them, I need a beam across this space. They say it's going to be this deep, it's going to be that long. And nobody questions it. Why is it this deep? Why is it that long? Why is it has to be rectangular? Why can't it be twisted? Why can't it go like this? We don't. And I'm sorry to say, in the US, they don't question it enough. In Europe, you have to actually give your reasons and let people understand more and more what you're trying to do and why you're trying to do it. You've got to be challenged. Anyway, moving through quickly, we went through all of this. These are some of the details on the cable option. By the end of the day, we abandon it. Because as soon as we convince the client that it doesn't quite work, so we spend about, 6 months working through all of that. So this should have we spend about 6 months dealing with all of this, and then we spend the other 3 4 months, and this is what we ended up with. To actually bring the light levels in this part of the world is something like, 6 times what it's like in Europe. So you have to bring the light levels down, solar gain, and all of that. We end up with, forget about the clear structure in glass or ETFE, we end up with solid, with lenses of light coming in, which actually created a beautiful space. Went through all the usual analysis, went through the usual materials. We tried to do it in timber. The areas in the forest was too big. The other thing is sustainability. You have to use the materials for what they're good at. I read in the press people trying to do the tallest tower in timber. That's its biggest little toss. Timber was never made to do more than 10 floors, because the amount of steel you have to then put inside the timber to work in composite with the timber makes no sense. But we can all write and put something in the press to say we've done the tallest timber building. Sorry, I'm not an advocate of them. Anyway, this is what's being built. This is how it looks, and inside. And these are the models, and it's on site. It's more advanced than this now. And hopefully it should be finished in the next 6 to 8 months. This is one of my favorite projects. And again, this is looking at design in a holistic way. The client on this rang me and said, look here, there's this site which got a built in 1976 brutalist building. You want to buy it, it's on the market, down to the last 4. What do we do with it? There's a planning permission to demolish it and put 5 mini towers around the site. So would you come take a look at it? The original engineers, who I'll not name, did the stuff for it and said you can add 4 stories to the tower and 1 floor to the podium building. We went to look at it, and I looked at it, and it was built in 1976. Precast external concrete brutalist. I used to sit on the panel on the planning for Southwark at the time, and I thought, what a waste to demolish all of it. Can you imagine the amount of energy you're using, the program, and this was when the conversation wasn't around. We now all talk about it, but this was done best part of, was the date on it? Completed in 2016. So it was 4 years, 5 years before that. And that conversation wasn't happening, especially on towers. You've got a 30-story tower, and this is what it looks like now. That's what it used to look like. That's what it looks like now. And that is not an image. Or is it? No, it's not. So, I love this project because we had to convince the client that we could put 11 stories on a 30-story tower without demolishing it, which is 30% more. But everybody got excited about that. But the lower building is 6 stories, and we added 3 onto it. 50% more. 50% more. We did not touch the foundations. We only strengthened columns where we created double height spaces in the lower areas. And the columns in the tower, we did not strengthen any of them. We even cut holes in the core to convert it from a commercial core to a residential core. So what we ended up doing, was this existing building. You can see the T-shaped building next to it it's all commercial. The whole thing was commercial. Yeah. So all of this and all of this is the site. So the whole thing was offices. What we created was the same area you've got here went into this level, which means from this level here all the way up became residential. And all the lower areas here became, for the big axis, became retail spaces, a destination space. So we convinced the client, and I said to the client, he says, I first said to him when we went, he said, how many stories do you think you have? I said, 8. Give me 24 hours, 8. And after a while, he came back to me and said, the figures doesn't add up. Can we do more than that? I said, well, we haven't had time to do the numbers. We did the numbers, and to tell the truth, he could have gone up to 13. But actually changing the load path and understanding how engineering worked back in the 70s. It's built, it's up. Why? The architects are American architects, KPS. And we work very closely with them. But why? Why do it? There's another one we're doing at the moment, sorry, because I really love this project. There's another one we're doing at the moment, which is a 17-story building, and we're adding 13 on it. And again, we're not touching the foundation, and that's on site at the moment. We're increasing the core. Look through the existing, understand what was done, understand the vision. We spent a lot of time understanding the vision of the original designers, a lot of research. Why did they do it? What was they doing? What were they trying to achieve back then? What kind of building was he trying to do? Now, what we have to do is adapt buildings. Everybody talks about, I'm sure some of you are going to qualify, going to go into the industry. I guarantee you they're going to be talking about we want a flexible space, we want a flexible this, we want a flexible that. To me, that is ridiculous. Why spend the time, money, energy to do a space when 90% of the time never get used for the flexibility? What we should be talking about is adaptability. So if I decide that this hall is not big enough, I'll knock that wall down, I'll redesign the corridors, and I'll make it work. I'll get the engineers in, and I'll make it work. Why spend the money and the energy to create this wonderful wall, put big structures in there, put this wall in there, make it so that you can blow it off in terms of flexibility, and it never gets used because 80–90% of the time, flexibility never happens. So it is the most stupid statement we use in our industry from a design point of view. So my view is change that word. So what we did was we post-tension the existing core, not by putting cables in it, not by tightening it up or anything like that. We just dump more load on it. We dump more load on it. Because when it was built back in the 70s, they used the core to support the building in terms of its. So the lever arm was the core. So what we did was we changed the core by having every single floor as an outrigger so that the external columns and the core are working together by increasing the lever arm. By dumping more load onto the core was designed to be tension, compression, tension, compression. By dumping more load on it, it never goes into tension any longer. Concrete is beautiful in compression. Concrete does not like tension. The only reason you use it for tension is pour a lot of reinforcement in it to make it work. Stupid, stupid, stupid. Seriously. So, by having this dialogue with the architects in terms of what they were trying to do in terms of the future of it, and we had the biggest row. I had the biggest row with the contractor, which was Mace. So much so that I was having a shouting match with the chairman of Mace at a meeting because I told him, not in so many words, these guys were morons. And this was an engineering project, not something you just, I got a tender, this is how we're going to do it. No, you got to do exactly what's on the paper. Luckily, I had the support of the client. is built, they use this as contractors to say, we are now the number one engineering building contractor in London because of this building. So I do believe as designers, we are in a position to help change the thought process of the industry. I was dragged to a planning meeting where the borough next door, Westminster, objected to this building, not from a case of planning issue. They said it was a piss take. It was an April Fool's Day. Well, trying to do a tall building in Southwark opposite Westminster, that it was not possible, that the client and the borough were taking the piss against Westminster. And the borough said, yeah, we got a finger up to you guys. We're the next borough across the river. But it was real. So I had to go and explain that, no, we are actually going to do this. We are going to make it happen. So I do believe as designers, we do have a thing to do. So this really simply explains it. So you got the core, and rather than the core doing all the work in the original, so this just shows the force diagrams, and this shows the complete. So you can see the original force diagram. It's got some tension. This is if you use the core, and again, you're creating a huge amount here, but by actually increasing the cantilever arm all around it, you actually keep everything in compression. Right? So we keep everything in compression. And by the way, we had a tube tunnel underneath as well, a small port. And it's all under in piles, but we did not touch the piles because the capacity we designed piles to, again, is criminal. A lot of wind analysis, and this gives you an idea of the carbon footprint. This is our bank tower, and we've used this just to give us some relative references. So AKT starts footprint, air flights we do, how much meat they consume, average city worker in our computers. You can see the difference, and here the amount of carbon saved on the two. This is the core. This is quite fascinating actually. We took the original core in red and we literally tore it to pieces, added some new bits to create a toilet, kitchen into those spaces. And the reality was we actually made it stronger at 7% from the original 100%. So anyway, this is just this is it going up, as you can see. I'm not joking why it was going up. London thought it was a piss take. They did not even believe it was going to happen, but it's done. It's finished. This is the final product. The internal is beautiful. And I can remember the Channel 4 TV rang up and said to me, they said, oh, we'd like to do a program on this thing and have it on TV. And the client got so excited. And he rang me and says, we're going to do this program. I said, no. He said, you're selling some of these spaces on the top for a lot of money. How would the client who's bought this beautiful apartment sitting there, knowing very well that next to him, there's a tension piles holding the whole 11-story extension together? They don't want to know. They don't want to know how it's built. You just want to know it's built. You don't want to tell them how it's done. So we decided not to do it. This is Bloomberg. I've put this one on because this got an amazing design story. Michael Bloomberg, who runs Bloomberg, decided that he wanted London, the city of London, financial center, has done his business very well, so he's going to create a space building. Norman Foster was the architect, and the chief planner of the city said, I do not want another Foster building. And Norman Foster said, I'm not going to give you another Foster building. I'm not going to give you steel and glass. I'm going to give you something else. And he did. But technologically, this is the first office building to hit BREEAM and LEED Excellent. The technology in this building is amazing. But when you've got a client that's prepared to spend over £1 billion on a 1 million square foot, now, people will question that to say, why are you spending £1 billion on a 1 million square foot? He's got the money, let him spend it. If he's going to use technology and funds to actually create a sustainable building, Go for it. Why do we have to, as designers, cost should not be a reason to do a bad design. Whether it's 20,000 or 200,000 or $200 or pounds. If you're going to do a piece of design, you better do the best you can for the amount. It's not about the money. It's about how you're trying to create something that is sustainable and environmentally okay. So the trick, the beauty on this one, and this job started, oh boy, a long time ago. The practice was 50 people when we started it. So it's something like about 12 years ago, 12, 15 years ago. And I can remember I rang the client, the development managers, so we like to work with them, and they say, you're not going to work with us until you're 100 people. It's not about size. That was my thing. Now, the most beauty about this building is about 10 floors. We also preserve the St. Paul's view. The views in London we cannot go past, and we preserve all of that. There's a huge amount of analysis that was done in terms of window. It's actually quite passive. You can open the windows. And it's got a very sophisticated environmental system. We use vacuum toilets. We use the least amount of water per head. It goes on and on and on. The accolade goes on and on. The light levels, we use tiny little LEDs to beautifully diffuse light. So glare and all of that is dealt with. Having said that, the facade cost per square meter is the same as a 5 Series BMW per square meter. So a lot of analysis was done. Bronze, hand polished facade. This is what it looks like. This is an old street that was re-established. And we had archaeologists on site for 6 months. Yeah, exactly. Where it's got the biggest amount of Roman artifacts came out of the site. Not only did we have that, we also had a Roman chapel that we had to move the basement from one side to its original position and bridge over it. We also had to solve the London Underground problem because after the King's Cross fire, they had to double end all the stations. So if there's a fire here, you can run there and get out. So we had to create a new station through the building. So we had to dig and put a station. We had to put a shaft, huge shaft, 22 meters down, all the way down. Now, the biggest challenge we had, these are all the artifacts, and there's a beautiful museum in this. This is the biggest challenge we had. But this is what I'm talking about, where you got to question everything. The black piles are the piles on the site. 3,000 of them. 3,435 diameter piles going down 18 meters. Yes. Now, the codes and the insurance companies say you cannot use existing piles because they will not warranty it. They will not insure the building. So when you're doing a new building, you have to put new foundations in. That is the biggest load of toss on the planet. The only reason it's there is for them to make money. They don't care about anything else. When we were doing this, and I'm going to be brutal a bit, our competitors were brought in, Arabs, because they're supposed to have one of the best geotechnical on the planet. And they wrote the code, the criteria for how you reuse piles. So their view was, we're going to spend about 200,000 of the client's money. We're going to test the percentage of these piles so we can say they're okay and we can reuse them. Right. Not a good idea. We said, no, we're not going to do that. They said, well, this is what the code and criteria said. And I can remember being in a meeting and I said, this is where we're going. And they helped write the code. And I went through it, so presented it. And I literally took it, went to the bin and chucked it in the bin. And said, no, why are you doing that? Think, we're engineers. We're not morons. And I said, why don't you cut down the piles? Because your problem is not the engineering, your problem is insurance companies. You're engineers, you're not insurance people. Why don't you cut down the piles, put some type 1 gravel, whatever, compact it, and put a raft on it? Because as you put the pressure on that, it will go through the soil. And as we all know from first principles at college, the hardest spot in the ground will attract the load, which is the piles. But from a technical point of view or from a legal point of view, the piles are no longer part of the building, they're part of the ground. And nobody goes around saying you've got to insure the ground. So get them off just get rid of them. Oh, no. Big row, big fight, big everything. So much so that the client got fed up and actually came to the US, to New York, and got, if you guys know who these guys, Ewan Cantor of Cantor Sinnock, they do all the towers, he's retired now. And he was brought out of retirement to come look at our approach. We did not meet the code and Arab's approach. And he looked at it and he said to the client, I will go with AKT. We saved, if you look at the red there at the new house, we saved a huge amount, not just financial, but environmentally, because the only way they were going to put new piles in there is to extract piles. And the worst thing you can do to a ground is extract some of the piles to put bigger piles in. So for me, it may be engineering is design. We had the architects support, this was Foster and Partners, to actually change the approach of reuse. And this was done, I don't know, 15 years ago, whatever. So the issue here is that I do believe that you guys, as I said, we fucked up the planet. Sorry about my French. But you guys have got the opportunity to change the narrative of design in the industry. You have to be prepared to challenge, to take it as far as you can, to question what is considered the norm. Who created the norm? It's almost the same thing in society where we use tradition and culture to divide people. It's exactly the same thing. So we have to do that. So it's built. The insurance company didn't say we're not going to insure it because they got a legal position to stand. Nobody said we're technically using the existing path, even though they do majority of the work. But that's where that's where we're going to go. Anyway, that's what I like about this project. It's beautiful. It's got some of the amount of steel we use horizontally rather than vertically could have made this shaft taller. So there were some compromises. We did the spiral ramp, which is there, and we also did a timber entrance thing, which is all formed, done in timber, a lot of analysis. It looks absolutely beautiful. This staircase is a double helix and it's actually only supported in absolute minimum locations. So the whole thing is built, and this one fosters their third sterling prize. So Foster's were quite pleased that they won the sterling prize 3 times. And AKT, we've won the sterling prize 3 times. And we're a lot younger. A hell of a lot younger. So again, comes back to, the views to St. Paul's and everything. The spaces are just amazing. This is the lighting. It's, I know it's bespoke, but it really talks about where we're going to go in the future. Very low energy usage, tiny little LEDs, very constant lighting, all controlled, very well controlled. And they also create a new public space, a new street. It's absolutely amazing. So if any of you ever end up in London, it is worth just going to the city to just see the building and walk around it. It's beautiful internally and externally. Back to the States. This is the vessel. I'm sure most of you have heard about it. This was an interesting conversation. Again, got a call from Thomas to say, because I rang him up years ago, and I saw the advert to the Shanghai Expo building, the Seed Cathedral, 2010, and I said, Thomas, this has got your name on it. And we entered the competition, and I can remember when we won it, the Minister of Trade at the time said, guys, I'm only going to give you one brief. I want this pavilion to be in one of the top 5, because they always judge the pavilion, which one's the best, second, it's got to be in the top 5. That's your brief. That's it. Go do it. And I'm not showing that today. And we looked at options and said, why don't we do spikes? So why don't we try and do 100,000 spikes, acrylic spikes, the aluminum sleeve, through the building so light can go in and out at the same time. Can we do that? Yes. Big problem. Big problem. We managed 60,000, mainly because of the scale of the thing. And I'm just going through this narrative because of the issue of challenge. We submitted it to the Chinese authorities, and we got there's no way you're going to build that. And it became literally a diplomatic problem. So told the client, the British government, to say, they're saying we can't do it. And the British government basically said, no, we are doing it, because part of the deal is that piece of land during the expo belongs to the UK. And we can do whatever we want on that piece of land. And the Chinese said, no, you didn't read the small print. You're supposed to make sure you take it all off and it becomes Chinese land again. So what's the problem? The problem was acrylic is not considered a structural material in China. They only use about 5 materials: concrete, steel, timber, and a couple of others. They do not consider acrylic. We did all the tests, everything. We presented it, went through the numbers. Eventually, I was in the office one day. I got a call to say, Albert, you're on a flight tonight, first class to Shanghai to meet the commissioner, the British High Commissioner of China, because we've got a big problem. They will not approve this thing. Went over. It was fun. I was sitting there watching these guys go for it. Nobody asked the real questions, but they were going for it. Eventually came to a compromise, and they got a professor from Chongqing University to go through all our stuff. We went through it, and I can remember he rang me and said, you must come over. I went over and he said, I'll tell you the truth here. Your design all works, but they're still not going to approve it because you're making them lose face. And they cannot. Politically, they cannot lose face. But the issue here is challenging the norm, and we end up with a bit of a compromise where we bundle the thing and we put the tiniest piece of concrete legs in, which technically doesn't support the building, but it saves face. And after it was done, it's all demolished, and given to all the schools and whatever. But I'm only going through that story just to give you. This one, very, very controversial from the beginning in Hudson Yard. I got a call to say, we're trying to do this thing. We spent about 18 months doing different kind of structure. And the question here is, can we create a space? If you go to Trafalgar Square and go to the squares in any city, really, you go there, you see this amazing monument, and you admire it, you take pictures, you go there. You know? Thomas was very clear. He wanted something that people can actually interact with, use. So he said to us, can we create this bowl, this staircase? And he drew it up, and I looked at it and said, this is crazy. We need to make the bottom a bit bigger, and we need to do this. He said, no. We need to make the base smaller even. I said, wow. And remember, this is sitting on top of a deck. And everything's on it. So it's not sitting on the ground, it's actually sitting on a deck. So can you imagine the vibration? And the issue there was that we had to use it had to be useful for a concert, riots, people listening to a band. It's got 2,500 steps. Going through all the steps is about just over a mile long, about 1.6 kilometers. 80 landings, all varying in terms of size. So we said, okay, we'll give it a go. And this is just to give a background of Hudson Yard on the right there. This is what the opening. And this was the idea. This is one of the early sketches. As you can see, the proportion of this bowl or vessel created a lot of problems because not only does it do that, it's also doing that. When you have 7,000 people in it listening to, I don't know, Jazzy B or one of these. So a lot of work was done, but also we had to modularize it so that it can be built. And we had a lot of, let me just go back to show you. So we went through a lot of options to create this sort of T-bone approach. And everything is fabricated from steel. We had another problem with that, challenging the industry on it. So it was all itemized. We went through full design on it. And the client was very clear that TT was going to be our delivery engineers in the UK, in the US, to go through all the approvals and everything. So a lot of frequency was looked at. What happens when you're, it's not going to be old people like me, it's going to be young people doing all the dancing on it. We just walk, we don't even strode anymore, but anyway. So went through all the frequencies and did all of that. And then the shape was the most difficult. We had to create a shape where the shape and the structure was the same. So it's not cladded. You even got a structure and then you clad it. The shape was the structure, the form. So a lot of parametric stuff was done, grasshopper, written things. And we also went through explaining how many people can be on it and what it means. And I must confess, these are some of the movement modes. I must confess, when we handed over our design to the engineers in New York, they shot themselves. When it went to the contractor, they struggled with it. But the first thing they did was say, which is something that needs to change in here in time, because the contractors have got too much power in terms of the influence they have on the design that's being given to them. They can go back to the client and say, this is all we're offering you. Forget what you want, this is what we're offering you. And there's not enough interaction between the design team and the contractors to make sure that what they're offering is close to the vision. It's so apart. So the first thing they did was abandon the design for a big tube, faceted, and then clad it. What that meant, they could not meet any of the frequencies with the tube. So after they spent about 6 months and a lot of money going through that process, they had to come back to us and say, okay, we haven't quite met what the whole purpose of the thing is. And they reduced it from, I think we had about 700 people jumping at high pace to something like about 200.